Okay, I'm Dave Caro. I'm on the product team at BlazeMeter. I just want to share with you some work we did to make it easier to convert existing legacy scripts, for instance, LoadRunner, VueGen, or TrueClient, or SoapUI. Basically, you have existing assets, and you want to put them part of a continuous testing process. It's much easier if you can do things with open source tools where you can put stuff in Jenkins, et cetera. So let's jump right in, though. So why are we doing this in the first place, right? And the short answer is that shift happens. Okay, anyone, show of hands, who's heard of shift left? Okay, what does shift left mean? Anybody want to give me an idea? Interesting, shift knowledge from the smartest guy on the right to somebody on the left. That's interesting. So shift left in the testing context means move your testing earlier in the life cycle and move it to a different place. Move it to where the code is built. So instead of building code in one place and throwing it over the wall to somewhere where it gets tested, shift left means start that testing where you're doing the coding. So that typically means a small agile team that's doing it. It could be an agile tester on the team, could be just a developer. It depends on your environment. But so when this happens, the themes we see in our customers is that they want to generally use open source. And why is that? Developers tend to be more interested in open source than proprietary tools. It's just a cultural thing that's going on right now. If you're a developer, you're more likely to want to play with open source than to learn something proprietary. So it's their preference. It's a very low friction choice. You don't have to get a PO or a purchase rec or ask your boss to download JMeter or other open source tools. You just download them, right? There's no gate, right? So there's no friction. It's easy to just get it done. You want to do a test, grab the tools, do a test, right? And there's a giant community where there's give and take, where people are sharing knowledge, creating plugins, doing things like that. So there's a much bigger community than any one vendor could control. And the next big thing is that people want every one of these separate teams. When you break into sort of more of an agile environment, you have multiple separate teams working in parallel. And one of the goals is for each of those teams to be able to do everything they can do all by themselves and not need to hand off and wait. Because handoff and wait sounds like delay, sounds like extra steps, sounds like communication that can get lost, right? So make every team self-service. Now, historically, performance testing, for instance, was done centralized. So if you had a small team that wants to move as fast as they can, and they want to run their tests as often as they do builds, or as often as they commit code, but they have to wait in line for a centralized resource to do performance testing, that's broken. Okay, and that's what we're out to fix. One of the things we're out to fix. So every team wants to be self-serve, be able to do things themselves. And then, of course, you want to be able to automate. It's one thing to sort of go through all the hoops as a human, but you want to actually build tests that run every time you check in code or every time you do a build, right? So that's what we're gonna get into. So I want to do most of this demo, not a lot of talk in the slides, right? So we're going to actually convert a LoadRunner VueGen script to JMeter. We can also create LoadRunner to Selenium if it were a TrueClient script. We're going to convert a SoapUI project to JMeter, again, so we can bring it into, and actually we're going to convert it to something called Taurus, and I'll show you that in a minute. That's a domain-specific language where you can just read it as English. We're going to do that so that, again, we can make it easier to use in all these tools. Then we'll actually demo running using a command line interface. We'll use Taurus, which is test automation running smoothly. It's an open source tool we gave away that lets you run these human-readable test definitions locally in a virtual private cloud or in the cloud, right? And then finally, we'll take a quick look at how you would integrate this into Taurus. So let's switch screens here. And first thing I'm going to do, oh, got it. All right, cool. Okay, so we are in the script converter now. And I'm going to refresh the screen so we got a freshie. Okay, so at shiftleft.blazemeter.com, we have a converter we're giving away which lets you do these conversions as simple as drag and drop, right? And so I'm going to bring up my Finder here, and I am going to go grab I have taken an entire LoadRunner project, zipped it up. I'm going to drop it in here, and let's see what happens. Okay, so it gets uploaded, and then after it's been uploaded, the script converter is going to parse that in real time. It's going to figure out what's in there. It's going to, if there's data files, it's going to convert them into CSVs that'll be linked to the files. So we're almost done uploading, and we've decided the file type is Vue.gen, so we're going to convert load runner to Taurus. And then when it's done, it's going to give us feedback. In this case, I deliberately uploaded a test that had a function, a function that's not yet supported in the conversion. It's the web concurrent start function. So we tell you, hey, listen, we parsed through all of that, and we found one unsupported function. And what we'll do is we'll actually comment that out, but we'll still create a usable test. So I click on this download from Blazemeter button, and here I have, on the right, I have a preview of the YAML file, but I want to actually download the whole goodies here. So I'm going to download, and I'm going to switch gears and come over to back to my Finder. And so what I've done is we created both a YAML file, which is this human readable thing. Let me show that to you now. First download. 1 second here. I seem to have lost one of my tabs. That's exciting for me. But I can find this stuff. Okay, so there's my YAML file, right? Okay, so I'll make this a little bigger. So this is a human readable file. It says there's a scenario. It sets some settings, and then it goes through and basically does the various requests. There's cookies in here, URLs to hit, et cetera. That's what the script was doing in LoadRunner. It's now doing it in a human readable open source format, right? This is a Taurus YAML file. That same conversion created a JMeter JMX file. And if I double click on that, I can see that in JMeter. And so now we see that very same thing that was in LoadRunner before, I brought up another one, is now also as a JMX and JMeter. And so if you were so the cool thing, we're out to democratize this, right? Create additional access to the tools. So if you know JMeter, great, you'd probably love this view. If you don't know JMeter, you don't even have to spend any time in JMeter. You could just look at the code, right? And you don't need access to LoadRunner to be able to do any of this, right? And so now I've got a JMeter test that's been created from that same thing. But what I want to do is I want to show how actually you use this in more of a developer environment, right? So let me cruise over to the command line and show you what Taurus is like. All right, so what I'm going to do here is I've gone down into the folder that YAML file is in, and I'm just going to say BZT, which is short for Blazemeter Taurus, star.yaml. It's going to run the YAML file. And what will come up is a sort of an ASCII art console showing us what's happening. Come on. Even though I've got my hardwired connection, I think they're being a little frugal with me on my my comings and goings. But it will launch. And then when it launches, we're going to see an ASCII art console. And we can also see what's happening. And here we go. So we can see what's being run. Over here on the right, I have local CPU and memory stats. Make sure my test harness is not the problem. On the left, I'm going to see data points about how many users I've run, response time, error rates, and I'll see some cumulative stats in the middle here. And give it just a second to actually get out to the net and get some results back. It's actually running from my laptop right here. So I'm running it on my laptop, but I'm hitting a target out there in the real world. And when the data comes back, this works better, obviously, if you're closer to what you're hitting. But this now is running the JMeter test for me. So now we're seeing the data points, right? So it loaded that YAML file. In the background, it actually created a JMeter test, launched JMeter, ran it, and is watching in real time the data coming back from JMeter. So now you get a sense that I can see immediate feedback about what's happening. Am I succeeding? Am I failing? What are the response times? I have percentiles in here for my response times. And I can see they're really, really high. So I've got a really bad problem out to the net from here. 18 seconds to get to an endpoint. Obviously, my connection's suboptimal. But let's use a nice familiar Control-C keystroke sequence to stop it. Trying to keep things simple, Control-C stops it, right? And then I'm going to rerun that same thing, but I'm going to put -report after that. what this is going to do is launch the same tool again, run it on my desktop again, but actually generate a report on the BlazeMeter platform. You can actually run reports on the BlazeMeter platform with a free account. You don't need a commercial account with BlazeMeter to see the reports of your local tests. Maybe it's a test that's running on Jenkins, maybe it's a test running on your desktop. And so what this is doing is this is going to launch, and since we got this latency here, I'm going to pop right over and show you what you would see, do the cooking demo approach here, which is that test that's running locally would report up to BlazeMeter, and I can see all the data there. I can even see things like the engine health, which is how busy was my laptop when this test ran. I'm actually running another test. There you go. So here I can see actually how busy the machine was. This is not the destination. This is the system, the test harness, right? So anyway, you get a sense that what we've done here is we've taken the proprietary tools and we're cracking them open and letting you convert them into open source artifacts so that you can then bring them into the development teams. You can bring them into GitHub. You can bring them into Jenkins. Speaking of Jenkins, if we cruise over here, Jenkins, Taurus is very easy to use in Jenkins because fundamentally it's a command line tool. So I have a project here where I don't know why my laptop is so bogged down right now. Anyway, I've got a project here which will let me, which has it's going out to GitHub and getting the source of a build each time, and then it's just running a command line down here at the bottom, running bzt and some YAML files. And a few options here and there, and that actually generates a test in the background, and then I can go see if I do a build now, I can fire this off. This would have been fired off by a code commit, not by me clicking build now, right? So if you committed code, this thing just gets run in the background automatically every time you commit code. Nobody has to think to do something. Nobody gets a help desk ticket. Nobody is asked to do a service task, right? And then you can go and you can actually see the console output. I'll show you the previous one that ran. So it shows what it did to launch. It shows a bunch of data points coming in, and at the bottom it shows that it was a success, right? If this was a failure, your build would be marked bad, immediate feedback, people fix things, okay? That's pretty much what I wanted to show, Eric. That's kind of end-to-end. Sorry for the rush on that. The network was my best friend here, but so you get the idea that we're really out to kind of democratize all of this and make it easier for any team to get access to testing feedback whenever they want it, and also to automate the heck out of it, right? So you should be able to automate, so stuff just happens day and night, and you only know about things when something goes wrong. So that is the end of my talk.